Welcome to SS2 Chemistry, Term 3, Week 11. Environmental chemistry examines how human activities, particularly those involving chemicals, affect the natural environment. Pollution from industries, vehicles, and agricultural chemicals is a major concern in Nigeria and globally. By the end of this lesson, you will define pollution and pollutants, identify major air pollutants and their sources and effects, explain water and soil pollution, describe the greenhouse effect and global warming, and answer WAEC questions on environmental chemistry. Let us begin. Air pollution involves the introduction of harmful substances, pollutants, into the atmosphere. Major air pollutants and their chemistry: carbon monoxide, CO produced by incomplete combustion of hydrocarbons, when insufficient oxygen is present. 2C plus O2 2CO, incomplete combustion, C plus O2 CO2. Sources: vehicle exhaust, petrol and diesel engines, burning kerosene stoves without ventilation, bushfires. Effects: CO binds to hemoglobin in the blood much more strongly than O2, affinity 200 times greater, forming carboxyhemoglobin, prevents O2 transport, causes headaches, dizziness, unconsciousness, and death, colorless and odorless, very dangerous because undetectable without detectors. Sulfur dioxide, SO2 produced by burning fossil fuels containing sulfur impurities and by roasting metal sulfide ores. S in fuel, plus O2 SO2. Effects: irritates lungs and airways, forms acid rain when dissolved in atmospheric water, SO2 plus H2O H2SO3 sulfurous acid, 2SO2 plus O2 2SO3, SO3 plus H2O H2SO4 sulfuric acid. Acid rain, pH 4.5 and below, damages buildings, limestone/marble, CaCO3 plus H2SO4 CSO4 plus H2O plus CO2, kills aquatic life in lakes, damages forest, corrodes metals. Nitrogen oxides, NOx, mainly NO and NO2 produced at high temperatures in vehicle engines, N2 plus O2 2NO from air at high combustion temperatures, N oxidizes to NO2 in air, NO2 reacts with water to form nitric acid, acid rain. Also involved in photochemical smog, NO2 in sunlight produces ozone and peroxy radicals which form smog, brown haze, affects Los Angeles, Lagos. Particulates, soot and dust fine particles from combustion, cause respiratory problems, absorb heat, involved in global dimming. Chlorofluorocarbons, CFCs formerly used in refrigerators and aerosol sprays, destroy the ozone layer, Cl plus O3 ClO plus O2, ClO plus OCl plus O2, each Cl atom can destroy up to 100,000 ozone molecules, chain reaction. The ozone layer, O3 in the stratosphere, 15 to 35 km altitude, absorbs harmful UV radiation from the sun, depletion increases UV reaching the surface, causing skin cancer and cataracts. Bound by the Montreal Protocol, 1987, replaced by hydrofluorocarbons, HFCs, and hydrocarbons. The greenhouse effect, solar radiation, visible and UV light, passes through the atmosphere and warms the Earth's surface. The Earth emits infrared heat radiation back towards space. Greenhouse gases, CO2, CH4, N2O, H2O, O3, CFCs, absorb this infrared radiation and re-emit it, trapping heat in the atmosphere, like the glass of a greenhouse. The natural greenhouse effect is essential. Without it, the Earth's average surface temperature would be about minus 18 degrees Celsius instead of the current plus 15 degrees Celsius. The enhanced, anthropogenic, greenhouse effect, human activities since the Industrial Revolution have dramatically increased the concentration of greenhouse gases, CO2, from burning fossil fuels, coal, oil, gas, and deforestation. Pre-industrial CO2 was about 280 ppm, current levels exceed 420 ppm, 2024. CH4, methane from cattle, enteric fermentation, rice paddies, landfills, and natural gas leaks. 84 times more potent than CO2 over 20 years, but shorter atmospheric lifetime. N2O, nitrous oxide from agricultural fertilizers, nitrogen cycle microbial processes, and combustion. Consequences of global warming: melting polar ice and glaciers, rising sea levels threatening coastal regions. Lagos is a coastal city at risk, more intense hurricanes and cyclones, shifts in rainfall patterns, desertification in the Sahel, coral bleaching, extinction of species due to habitat loss. Nigerian context: the Sahara Desert is expanding southwards into the Sahel. Desertification: Lake Chad has shrunk dramatically over the last 50 years, partly due to reduced rainfall linked to climate change, flooding in delta regions, threats to coastal cities. Water pollution: causes: untreated sewage, introduces pathogens, depletes dissolved O2 through biological oxygen demand, industrial effluents, heavy metals, lead, mercury, cadmium, chromium, bioaccumulate in food chains, toxic organic chemicals, agricultural runoff, excess fertilizers, nitrates and phosphates cause eutrophication, excessive algae growth, depletion of oxygen as algae decompose, death of fish and other aquatic life, oil spills, crude oil pollution in the Niger Delta. Smothers aquatic life, contaminates drinking water, destroys livelihoods. Acid rain, lowers pH of lakes and rivers. Effects of water pollution: waterborne diseases, cholera, typhoid, dysentery from fecal contamination, heavy metal poisoning, neurological damage from lead and mercury, Minamoto disease in Japan from mercury pollution, eutrophication, loss of aquatic biodiversity. Soil pollution: causes: excess agrochemicals, pesticides, herbicides, fertilizers, industrial waste dumping, mining activities, acid mine drainage, oil pollution, heavy metals from industrial activity. Effects: loss of soil fertility, bioaccumulation of pollutants in plants eaten by animals and humans. Control measures: proper waste disposal and treatment, sewage treatment plants, industrial effluent treatment before discharge, use of biodegradable chemicals, organic farming, reduce synthetic agrochemical use, phytoremediation, using plants to absorb heavy metals from soil, oil spill cleanup, physical removal, bioremediation, using bacteria that break down hydrocarbons, international agreements. WAEC questions on environmental chemistry commonly test: writing chemical equations for formation of acid rain, SO2 plus H2O H2SO3, SO3 plus H2O H2SO4, explaining the greenhouse effect and naming greenhouse gases, CO2, CH4, N2O, H2O, CFCs, explaining the ozone depletion mechanism. CFCs release Cl radicals which catalytically destroy O3, distinguishing between the natural and enhanced greenhouse effect, explaining eutrophication, excess fertilizers in water, excessive algae growth, O2 depletion, death of aquatic life, identifying effects of CO on the body, binds hemoglobin, reduces O2 transport, naming sources and effects of major pollutants, discussing the environmental impact of the petroleum industry in Nigeria, Niger Delta oil spills, suggesting methods of pollution control. Essay questions in WAEC often ask students to discuss the causes, effects, and control of air/water/soil pollution, explain global warming and its consequences, discuss sustainable development and environmental protection. Key points: air pollutants, CO, incomplete combustion, binds hemoglobin, SO2, burning fossil fuels, causes acid rain, NOx, and high-temperature combustion, acid rain, smog, CFCs, aerosols/refrigerants, destroy ozone layer, particulates, respiratory problems. Acid rain, pH below 5.6 from SO2 and NOx plus H2O in atmosphere, damages buildings, kills aquatic life, harms forest. Ozone layer, stratospheric O3 absorbs UV, CFCs destroy it catalytically, Montreal Protocol bans CFCs, greenhouse effect, CO2, CH4, N2O absorb and re-emit infrared, natural effect is necessary, enhanced effect from fossil fuels is causing global warming. Consequences: rising sea levels, extreme weather, desertification, species loss. Water pollution, sewage, industrial effluents, agricultural runoff, oil spills, effects, disease, eutrophication, bioaccumulation. Soil pollution, pesticides, heavy metals, oil, causes loss of soil fertility and bioaccumulation. Nigeria-specific issues, Niger Delta oil spills, lake chart shrinkage, desertification of the Sahel, flooding in coastal cities.